So when we look at alternating series, we have some terms of an alternating series that are positive. We have some terms that are negative. And when we do the series, or we sum this all up, some of these positives and negatives will work against each other, and they will more likely tend to converge versus diverge. So what happens when we have an alternating series, and what makes them converge? So there's a theorem that says, it's Leibniz's theorem, and it says that if the terms alternate and the terms go to zero, the series will converge. Okay, so we saw that with the alternating harmonic series, which converged to ln 2. So, but as long as it doesn't have to be the harmonic series, it's as long as any series, as long as the terms get smaller and smaller and smaller, those series will always converge. Okay, and we can just geometrically just show you why. Because we end up with this first term. Let's say the first term is positive, it goes that way. And then we have a second term is going to be negative, but it's going to be smaller than the first term. So it never will pass the tail of the first term. And the next term being positive is going to start at that tip. And since it's smaller, it will never pass the tail of the previous term. And if this is continuing, what's going to happen then is it's just going to keep going back and forth, and it will never be able to break the bound of the previous term. So you end up with this natural sequence that will converge at some limit. Okay, you will end up having it at a limit. So as long as it alternates and each term gets smaller, these series always have a limit. Okay, so these are always converging, and they will converge to a limit. Now, whether we can actually find the limit again is up for question and not relevant to us. The fact that they're converging is what's really relevant. So if I take a look at this series here, we can take a look at something called absolute convergence. Okay, so when we have this property, we know that it converges, and we call this conditional convergence. But there is something called absolute convergence, and this is when the series converges regardless of alternating terms. Okay, having some negative, some positive. Okay, the fact that for these absolute convergence, the fact that some are positive and some are negative will help the series converge. But we're gonna look at these and say, well, even if they don't alternate, does this series converge? In this case, it does. Okay, and we'll show you why. So we have this series, sine n over n squared, and as we plug in n values of 1 to infinity, some of these terms are going to be positive and some of them are going to be negative. It doesn't quite alternate. It's just that we know that some are positive, some are negative. You know, we could have a few positives in a row, we could have a few negatives in a row, but this has some negative terms in it. Now we want to know if this converges. What we can do is this. We can just look at this problem like in this way. We can say that, well, we know that if I do this, okay, if I put the absolute value around this, if this converges, then the series that have some positives and negative terms must also converge. So we're going to test this for what we call absolute convergence. Okay, so we're going to say that sine n is always going to be less than or equal to 1. So then we can compare this and say, well, sine n from infinity of sine of n over n squared, that series is going to be always less than the harmonic series. Sorry, not the harmonic series, the basal series. Okay, and because of this, and I'm just going to highlight this, where this statement allows us to make this change. Okay, so then what we have then is we have a converging sequence. We know that this is convergent. Therefore, both series converge. And not only do they both converge, this one here now, we say that it converges absolutely. So we know that sine of n over n squared converges absolutely. So it doesn't need any help to converge. Essentially what that means, this converges regardless of whether we have positive or negatives. It doesn't need any help for it to converge.